The solar supply chain threatens our climate goals with recent disruptions, including the pandemic, problems with international conflict, and import seizures due to forced labor in China. The silicon wafers that power 95% of the world's solar panels are at the heart of these challenges. Because we cannot compete on cost, wafers have not been produced here in the US since 2016. Manufacturing silicon wafers is so complicated that over 90% of wafers available globally are produced by just 2 overseas companies. At Leap Photovoltaics, we are developing a groundbreaking manufacturing process that eliminates wafers, going from refined silicon directly to finished solar cells. This approach links the pieces of the solar supply chain that already exist in the United States to create entirely American-made solar. Our breakthrough combines recent advances in additive manufacturing, coating technologies, and the formation of electrical contacts in commercial silicon solar cells that enable us to retain the performance and reliability of silicon solar cells while consuming 90% less silicon and 70% less energy than wafer manufacturing. This combination means we can match the performance of imported cells using domestic supply chains with globally competitive costs. Existing alternatives to the wafer supply chain either try to make wafer manufacturing simpler or to replace silicon with thin film materials. Leap projects lower cost and better performance than kerfless silicon wafers, higher efficiency potential than traditional thin films, and better reliability than perovskites. Customers we have spoken with will not accept performance trade-offs, but are eager for Leap's technology's local supply chain and cost savings. Through our prototyping process, we tested 4 key components of solar cell performance highlighted by customers, manufacturing partners, and investors to demonstrate performance equal to wafers. Optical absorption, electronic material quality, low electrical series resistance, and high resistance to parasitic current flow equal to wafers have been validated by third-party measurements at universities and national labs. Our new collaborations with ASU and NREL were enabled by our success in the set phase of the American-Made Solar Prize, including the vouchers we were awarded. During the Go phase of the American-Made Solar Prize, we have gone from proof of concept to prototyping and are on our roadmap to achieving state-of-the-art efficiency. The Solar Prize enables Leap to prove our process and configure it for production, which will start in 2023. Winning the Ready and Set phases, as well as recently being awarded the CalSeed Prototype Award from the California Energy Commission, enabled us to significantly expand our engineering team.
When we first applied to the Solar Prize less than a year ago, our team consisted of 1 founder and 1 part-time CFO. Today, we are a team of 5, who have successfully taken our technology from concept to prototyping, signed early customers, and expanded into a new lab. Now we continue to grow the team as we transition into pilot manufacturing. I'm David Burney-Needleman, and for the last 15 years, I've been working with universities, national labs, startups, and major solar manufacturers to develop and manufacture the best solar cells in the world here in the United States. That's why I founded Leap Photovoltaics. Let me introduce the rest of our team. Matias Machado, our co-founder and CFO, has executed dozens of financings for high-growth technology companies and also worked on the engineering side, developing solar energy and other infrastructure projects. Matt Robinson has a unique background. Few, if any, engineers can match his technical expertise in printing techniques, coatings, and processing and manufacturing of inorganic solar cells. He also spent 20 years working in startups, from launch to successful exits. Elena Pandres and Rajgopalan Ramesh bring complementary technical skill sets in fabrication, characterization, and simulation of photovoltaic and other electrochemical and electrical devices. Elena is leading our collaboration with NREL using vouchers from the set phase of the American-Made Solar Prize, as well as a collaboration with the Washington Clean Energy Testbeds. Rajgopalan is leading our work developing fully passivated low-resistance contacts at the Solar Fabrication Lab at Arizona State University. Our partners at Materials Research LLC have over half a century of collective experience with specific coating processes and equipment critical to achieving our goals. Our initial goal is to sell to US module manufacturers who already purchase about $600 million of solar cells each year. We will work with these customers to build their market share in the US and expand into overseas markets, projected to grow to $40 billion per year by 2030. During the Go phase of the Solar Prize, we executed a second LOI, signing up customers for our first 1 million solar cells. We also secured firm commitments from these customers to test our first solar cells in order to unlock larger purchase agreements for the $40 million that they expend on cells annually. Success in the American-Made Solar Prize will enable us to realize our vision. We will enter pilot manufacturing in early 2023, at a new facility with the capacity to produce 10 megawatts of LEAP solar cells per year. In addition to support from DOE, we have received commitments from investors in our first round of private capital to build out and operate this pilot line through 2023. This investment in facility will enable us to deliver on our LOIs and test cells with customers next year. Demonstrating performance with these early customers will position us to bring solar cell manufacturing back to the US and generate thousands of jobs over the next 5 years. We aim to build America's first ever gigawatt-scale silicon solar operation in 2025 to truly leap into a new era of US solar manufacturing.